Today's lesson is 1.1 Points, Lines, and Planes. Points, lines, and planes are considered undefined. They have no definition because they can only really be explained using examples and descriptions. A point is written as a dot. It has no dimension, length, or width, and it is named by a capital letter. So if you go ahead and take a look over here at our example, this right here is your point, and then we're not graphing in geometry, we're using it to name stuff. So you're going to see a capital letter next to it. We do not use lowercase letters, that is incorrect. You must name with a capital letter a point. All right, moving on. A line has one dimension, which is length, and it extends without end in two directions. It is represented by a line with two arrows. So when we graph in algebra, a lot of times you see a line like this. In geometry, we must say that it is a line which is continuous in two directions, so it has to have the arrows. And then you would see a minimum of 2 points on that line. There are many more. They've chosen on here on the graphic to show you 3. But you have to have a minimum of 2. That's because if I am going to name this, if I'm going to name it, I can use any 2 points. Okay, so through any 2 points, there exists exactly one line, and you can use any 2 points on the line to name it. So if I were to name this line up above, I could call it A, B. I could also flip them and say BA, that's the same thing. I could name it BC, or I could flip them CB. And the last one is AC, and then of course I could switch it CA. Now, if I just were to name it like this, you don't know if I'm talking about 2 points, A and B. Am I talking about the line? Am I talking about, we're going to learn a couple more that we're going to talk about today. So you have 2 options. You can write the word line in front. So I could actually add that to each one of them. This is not my choice. So notice I'm doing this with my laser pen. I don't really necessarily want to. I want something that's a little bit quicker. And so there's a symbol for the line, and it's simply a straight line with the arrows on both ends. So there's line AB, line BC, line AC, and they're all talking about this line right here. You can also come around and do this, and this. This line has 6 different names. All of them are correct. None of them are wrong. The only thing that you would maybe get points docked on is if you do not add the symbol above. You can get away with not writing the symbol if you write the word line. So if one of those 2 is not there, then yes, I'm going to take off points because you just use the letters. All right, we do have something called collinear points. Collinear points, oops, hold on a second. There we go. These are points that lie on the same line. So if you look at our picture right here, A, B, and C would be considered to be collinear because they all lie on the same line. If I were to take a point right here and call it D, this one is non-collinear because it is not on the same line as A, B, and C. All right, let's go ahead and take a look at this first example. Here is our picture, and for the first one, they want us to name 4 points. Well, we just learned that the points are these little dots right here. So I'm going to go ahead and name them. I'm going to name them from the left to the right. So here we go. M, comma, G, comma, E, comma, O. I want to make sure that I put a comma in between so that I can see that there are 1, 2, 3, 4 points. If I were to just write them like this, This is looking more like what we're going to see when we go to a plane. So the more letters you put together without defining them as separate, the more they look like another figure in geometry. So it's very important that we get that comma in between. Name two line segments. Well, a segment is just a part of a line. And so all I have to do to name a segment is pick up a piece of the line. Here is the line. And so a segment would be like from G to E. So I'm going to go ahead and put the letters G and E. It's my choice. I could flip them. That's okay. And the symbol for a segment is simply a line. A segment does not have a beginning. Well, it has a beginning and it has an end. So it does not continue on in either direction. So it's just a straight line. I need one more. So let's go back to our line. I can use E and O. I could use G and O, that would be a segment. I could even come up here to this one right here and put M and E. Those are all segments. So lots of different answers for this one. I'm going to put E and O and the line up above. All right, name three rays. Well, a ray has a beginning, it has an end point, like a beginning point, and then it continues on in one direction. So right here, this is my classic ray. It starts and it continues on. When I name a ray, I always name it by its end point. So I would have to name this one EM. Now they want three, so I'm going to put a comma and I'm going to put two more. The other two rays that are on this line are on the line. Okay, I have to use the points G, E, and O, and I must use two of them to name the ray. That means E has to be my beginning point. So one ray from E is going to go in this direction towards O, and the other ray is going to go in that direction towards G. So I'm going to have EO and EG. Those are my other two. The ray symbol always points to the right of my page. It never points to the left. It doesn't go by what the picture looks like. The symbol is always the same. Think about it. If we switch the symbol around, then we might not know what to expect. Just like, let's say, Burger King. If they all of a sudden, there was a Burger King and then there was the King Burger, would you think they were the same? I wouldn't. I would think the King Burger probably serves something a little bit different than Burger King. All right, name two angles. Angles have to look like this. We've seen them before. They have to have a vertex and then they have to continue in two different directions. So here is an angle that I see right away. It kind of looked like the one I just drew. When I name it, the vertex right here needs to be in the middle. And so I can start at G and then go to E into M, or I can start at M and go to E into G. So I'm going to say M, E, G, and the angle symbol is this one right here. Now it might be a little bit deceiving, but the other angle that is there is this one right here. It can be a little bit tricky because it is larger, but there you go. Ease the vertex again, and we could go M, E, O. There we go. Now the last thing they want us to do is to name the line in three different ways. Well, we did that with A, B, and C. Remember that you only need two of these 3 points to name the line, and you can use them in any order. So G, E, E, O, and G, O would be my 3 names. I do have to come in here and put the symbol because without the symbol, they are not technically lines. There we go. All right, a plane, oops, there we go. A plane has 2 dimensions. It has length and width, and it extends without end, which means it has no edges. It is represented by a shape that looks like a parallelogram. So this is what in geometry we normally see a plane to look like, but really it's continuing outward to the left and to the right, it's continuing up, and it's continuing down. You do notice that there are 1, 2, 3 points on the plane and that there is a capital letter over here in the corner which has no point. Let's read on. Through any 2 points not in the same line, there is exactly one plane. You can use 3 points not in the same line to make a plane. So when you name it and when you make it, when you name a plane, you need 3 points that are not in the same line to name it. Basically, what I do is I look for 3 points that can create a triangle. So if I were to name this plane, I could name it A, B, C. And it is just commonly understood that if we put 3 letters together like this, we are talking about a plane. So when I see 3 capital letters with no space in between them, no comma, I know you're talking about a plane. Um, that capital letter M in the corner that has no point next to it is another way of naming it. But if I were to choose the capital letter M, I would have to, oops, see, I said M and so I wrote it plain. There we go. I could name it plain M. Now I don't want to just call it M. I do want to make sure that I put the word plain in front of it if I'm using M, because if I just use the letter M, then I would be insinuating that it is a point, and M is not a point because there's no dot by it. All right. Coplanar points are points that lie in the same plane. Very similar to what we just saw with collinear. Coplanar just means same, planar, plane. Let's go ahead and take a look at example 2. Name 3 collinear points. So I need to find collinear points, 3 points on the same line. There they are, D, E, F. Make sure that you are separating them with a comma. Name 4 coplanar points. Stay on your plane. Here is your plane. You want the ones with the dots, G, D, E, and F. Notice H is up above and R does not have a dot. G, D, E, ooh, I can do better than that, you guys. E, and F. Name 3 non-collinear points. Now this one's a little bit tricky. Non means that they're not on the same line. So all I need is 1. I just need 1 that's not on the same line as the other 2, and then we are non-collinear. You could do 3 of them that are totally not on the same line, but all you really need is 1. 1 that's not on the same line as the other 2, and you are fine. So I could say D, and then I could pick E or F, or I could go ahead and pick G, and then I could go ahead and pick H. All of those, if you take a look at them, they are not on the same line, not at all. Now, could I technically draw a line here? Yes, I can. And so then they would be collinear. But it's because of H that makes them not. Okay. Instead of D, I could have picked E or I could have picked F. Instead of G or H, I could have picked E or F. All right, which point is between D and F? Which point is between D and F? All you got to do is find D and F, and then what point's between them? E. That one was pretty easy. Name a point that is not between D and F. Name a point that is not between D and F. Well, there are 2 of them. There is G over here and H over here. Now, you might be thinking, Miss, what about N? Well, this N is here to help us name this line. Notice that this line, we could call it HE, but then we might want to call it just line N. And so if you see a lowercase letter next to a line, that's another way that you can name that line. It's not always used, but it can be used. Are collinear points also coplanar? Are collinear points also coplanar? Sometimes. That's going to be my answer. And let's take a look at our picture. D, E, and F are coplanar. H and E, however, they are not on this plane. They are on a different plane that's not drawn. Even though it's not drawn, it doesn't mean that it's not there. It's just, it's not there in the picture. So sometimes, but I don't know if I can jump out and say always. I don't know if I want to jump out and say yes all the time. Are coplanar points also collinear? Well, I'm going to say not always. And take a look at G. G is going to be my example. G is not collinear to these 3 points. It could be collinear to D. It could be collinear to E. I can make a line there. It could be collinear to F, but it cannot be collinear to all 3 of them. All right. Some defined terms, and we kind of already talked about these in example 1. A ray, let me go back here, there we go. A ray, which is used by this symbol right here, AB, it consists of an endpoint, which is A, and all the points on line AB that lie on the same side of A as B. So here would be B is my endpoint, and it's going this way. CA and CB are opposite rays. Opposite rays if C lies on AB between A and B. Let me draw that out for you. So here is my line. There we go. And what this is saying is that I have to have A and I have to have B on the line. And then if C is in the middle, then what I have are 2 opposite rays. I have a ray going this way, which is this one. And then I have a ray going this way, which is this one. And notice together, if I were to just highlight all together, these 2 colors are making my line. They're making my line. So that was what an opposite ray is called. But normally a ray just starts and then continues in one direction. I could call this ray AC, or I could call it AB. Doesn't matter. This one, even though it's going in this direction, I would call it BA, or I could call it BC. It doesn't matter. All right. A line segment consists of 2 endpoints, A and B, and all the points on line AB that lie between A and B. So this is normally what a line segment looks like. But just like we did in example 1, I can take my line here and I can create it into segments. There's a segment between A and C, here's a segment between C and B, and here's a segment between A and B. It's just like I'm chopping off the rest of the picture. This point, of course, out here, I could use it to create segments if I wanted to, but it's not on the line, it's not collinear. All right, example 3, and I think this might be our last one. True or false? Taking a look at the picture, true or false? Points J, D, and F are coplanar points. J, D, and F are coplanar points. I'm going to go ahead and say, based on this picture, that is false. Could I put a plane on those 3 points? Yes, I could. Based on the picture, false. In real life, could I create a 3rd plane right here? Yeah, I could. There's another parallelogram. But based on the picture, I'm going to say false. A and C are collinear points. Now, because they are on the same plane, I'm going to go ahead and say that is true because through any 2 points, I can create a line. Just because it's not drawn doesn't mean it's really not there. The intersection of plane P and line JB is the point B. When a plane and a line intersect, they do intersect at a point. So all I need to do is find plane P. Here it is down here. And then I need to find line JB. There it is. It is intersecting right there at B. So yes, that is true. Plane BDF, so I'm just going to go find the letters B, D, and F. Okay, so I have to kind of think. Okay, is another name for plane Q. Is that another name for this plane Q? False. B isn't even on that plane with D and F. Points J, D, and B are collinear. J, D, and B are collinear. Can I make a line? Yes, I can. That is true. DH, ray DH, and ray DE are opposite rays. So that means that they both have to start with the same letter and they have to go in opposite directions. If I were to connect it all together, it would make one straight line. That is true. The only way that that would be false is if D was here and F, let's say F was there, and then let's say H was up here. This would be false. These are not opposite rays because one's going up and one's going to the right. They have to go in completely opposite rays and make a line. They have to make a line. All right, points E, D, and C are coplanar. E, D, and C are coplanar points. Based on the picture, no. Could I make them? Could I make a plane between them? Yes, but I'm going to go ahead and say false based off the picture. Okay. Ray DJ, and ray DB are opposite rays. Now it's looking good because they both start with the letter D, but remember you got to look at the picture. So it's DJ, good, DB. Do they make a straight line? Yes, they do. They don't do that funky thing. So I'm going to say true. And that's it. Good luck on your assignment.